All right, let's talk about Apache Spark. If you're in the big data world, you know it's an absolute beast, a real powerhouse. But you also know that feeling, right? That frustration when a job just crawls? Well, today, we're going to fix that. We're diving into 5 key strategies to supercharge your Spark applications so they run faster, more efficiently, and honestly, are just way less of a headache.
This is the question, isn't it? The one every single one of us has asked, staring at a progress bar that just isn't moving. You've written perfect code, you hit run, and then you wait. And you wait some more. So why? Why does this happen? Let's dig in and find out.
Okay, so let's get right to the heart of it. Here's the thing about Spark. It's incredibly powerful, for sure, but its out-of-the-box settings, they're generic. They're built for any job, not your job, with its massive, unique data set. And when your data really starts to scale up, those defaults can hit you like a brick wall.
And this is exactly where things get painful. You've got all this data, all this potential, but your job is just stuck in what feels like a digital traffic jam. These bottlenecks, they're not just annoying, they're expensive. They burn through time, they burn through cluster resources, and that means they burn through money. So figuring out what's causing them, that's step 1.
All right, let's play detective for a minute. If we want to speed things up, we've got to find the culprit. And you know, in the world of Spark, there are a few usual suspects, but there's one big one that's almost always the main offender.
And here it is, the #1 performance killer, data shuffling. So what is it? Well, anytime Spark has to move data around between the different machines in your cluster, like for a join or a group by, that whole process is called a shuffle. And you need to remember this. It is, by far, the most expensive, most time-consuming thing you can ask Spark to do, period.
This analogy is just perfect for understanding why shuffling is so slow. Seriously, picture a giant, chaotic mailroom. Every single row of your data is a letter, and it needs to go to a different house in a different city. The shuffle is that mailroom, frantically trying to sort everything, package it, and then send it out over the network. It's a massive amount of network traffic, a ton of writing to disk. It's organized chaos, and it's exactly where most jobs just grind to a dead stop.
Okay, enough about the problem, right? The good news is we're here to talk about solutions. We've boiled it all down to 5 supercharged, actionable strategies you can start using right away to fight these bottlenecks and get your jobs flying again.
Yep, just 5. Why only 5? Because these are the big ones. These are the strategies that give you the absolute biggest bang for your buck. And you don't need to be some guru who knows every single Spark internal. Honestly, just getting a good handle on these 5 things will completely change the game for you.
So here's the plan. First, we're going to tackle that big shuffle monster. Then, we'll talk about organizing your data with partitioning. After that, it's all about smart caching, tuning your memory and garbage collection, and finally, using the most efficient data formats. Ready? Let's jump into strategy number 1.
Okay, rule number 1 is simple. If shuffling is the enemy, we have to avoid it whenever possible. So how do we do that? Well, first off, filter your data as early as you can. I mean, right at the start. The less data you're carrying through your pipeline, the less data there is to shuffle later on. It's that simple. And second, here's a huge one. If you're joining a big table with a small one, use a broadcast join. This is so cool. It just sends a copy of that small table to every single worker node. No shuffle needed. It's an absolute game changer for join performance.
All right, next up is partitioning, and it's all about working smarter, not harder. This library analogy is perfect. Imagine your data is a massive, completely disorganized library. Finding one specific book would be a nightmare, right? You'd have to search every single shelf. But if it's all neatly organized by genre and author, boom, you go right to it. That's exactly what partitioning does for Spark. It groups related data together, so Spark knows exactly where to look.
So the goal here is to get your partitions just right. It's like Goldilocks. Too few partitions and you're not using all your workers. No parallelism. Too many and the management overhead just kills your performance. The biggest thing you want to avoid is something called data skew. That's when one poor worker gets a massive partition to chew on while all the others are just sitting around finished with their tiny ones. It's a huge bottleneck. You want everyone to have a roughly equal amount of work. Oh, and here's a pro tip for you. When you're ready to write your final data out, use Coalesce. It's a super efficient way to reduce your partition count without triggering another big, expensive shuffle.
Strategy number 3 is all about a simple principle. Don't do the same work twice. I mean, think about it. If you've got a complex process, or maybe you're training a machine learning model where you use the same data over and over again in loops, why on earth would you make Spark recalculate it from scratch every single time? That's where caching comes in. You just tell Spark, hey, Hang on to this chunk of data in memory for me. Then, the next time you need it, it's right there, instantly. It can save you an enormous amount of time.
Okay, let's pop the hood and talk about the engine room, memory. Getting your memory settings right is absolutely critical. If you give your executors too little memory, Spark starts spilling data to disk to make room, and that is super slow. But give it too much, and you can get slammed by long garbage collection pauses. You know, GC is just the process of cleaning up old junk in memory, but if it takes too long, your whole application just stops. Everything freezes during the cleanup. So for jobs that need a lot of memory, a great tip is to switch to a more modern garbage collector, like the G1 GC. It's designed to minimize those long pauses and keep your job humming along.
And our final strategy gets right down to the foundation, the format you use to store your data. This comparison says it all, really. Think about a CSV file. If your query only needs one column out of 100, Spark still has to read the entire bloated row just to get that one piece of information. It's so wasteful. But with a columnar format like Parquet, it's completely different. Spark can go in and grab only the columns it needs. For any kind of analytics work, this is just a massive, massive win.
And while we're on the topic of data formats, here's one more pro tip for you: cryo-serialization. Okay, so whenever Spark shuffles data, it has to pack it up to send it across the network. This is called serialization. The default Java serialization is fine, it works, but it's like packing a suitcase by just throwing stuff in. Switching to cryo is like using one of those vacuum-sealed bags. It's way more compact and way faster. It's a simple switch that can really speed up those shuffles.
So, we've really covered a lot, haven't we? From big ideas like avoiding shuffles, down to the nitty-gritty of memory tuning. The key thing to remember is that none of these strategies works in isolation. A truly fast, efficient Spark job is where all these pieces are working together in perfect harmony. Look, if you walk away from this with just 3 things, let it be these. Number 1, filter early, always. The less data you process, the faster you'll be. Number 2, partition wisely. Make sure your work is balanced across the cluster. And number 3, choose columnar. Use Parquet. It is one of the single easiest wins you can get. Seriously, just mastering these 3 things will solve probably 90% of your performance issues.
And that really brings us to the final, most important question. See, tuning your jobs isn't something you do just once. Your data is going to keep growing. Your analyses are going to get more complex. The real goal of everything we talked about today isn't just about fixing the slow job you have right now. It's about building a strategy that can scale with you into the future. So I'll leave you with this. Is your Spark strategy ready for what's next?